All right, hello everybody. Hello. Nice to see you all. So I'm here to tell you about how to play the long game, which is kind of a difficult thing because it's very hard to nail down what the long game even looks like. So why is it hard? Well, the signal to noise ratio is awful. There's so much hype and there's so many really cool things that are happening at the same time. There are emerging best practices and many new and exciting ways to shoot ourselves in the foot. There's a deluge of new tools and opinions, and AI fatigue is a thing. Who feels it? It's a thing, right? And on top of that, roles are changing, organizations are changing because bottlenecks are changing and human interactions are changing. And so it's a very difficult thing to stay on top of. On top of that, there are economic concerns and environmental concerns. So who here thinks that there's going to be such a thing as a software engineer in 5 years' time? Okay, cool. All right. Yeah, me too. So, hello everybody, my name is Sheena. I have been working in software engineering for quite a long time. I learned to code like 25 years ago or something like that. I look after my skin. At my heart, I am an educator. I take the science of education and I turn it into different mechanisms that set people up to learn and grow and flourish. For a long time, I did that in South Africa for a non-profit. So basically what we did was we found high potential young folks and we trained them up and we got them jobs. This wasn't one of those interview hacky boot camps, you know the ones. This actually set people up for careers. They'd get a job, they'd keep the job, they'd progress. So that was cool. Now I have my own company called Prelude where we do more advanced Python training and teamwork training because teamwork makes the dream work and people don't really teach that stuff. Did I mention I like teaching? So I started a free and open community called the Guild of Educators for anybody who's interested in teaching code because we have a lot to talk about. I'm also very involved in the Python open source community. So I'm one of the directors of the Python Software Foundation. So that's the organization that looks after the Python ecosystem, both the community and the infrastructure. I organize conferences. So most notably, PyCon Africa 2025 last year. I was the chair. I am in fact an African. Cool. So why do I get to talk about this? I'm not like an ML expert, but it's very relevant when it comes to education. So preparing people for the future is like my whole thing. That's what I care about. And the future is a funny place. And I work with people at multiple scales. I've trained individuals up to organizations. And it's really, it's tricky. Like I need to have my head wrapped around the stuff in order to get this right. But on top of that, because of my interactions with the Python community, a lot of young folks come to me for advice, and that's terrifying because I don't want to encourage somebody to go into a career that's not going to exist or dissuade somebody from a career that they'd actually be really good at. So for me, it's like I want to stay on top of the stuff. All right, so what are we doing here today? Today I'm going to be sharing my latest thinking, what I believe. But I don't think it's the final word because, again, things keep changing all the time. And if you see something in here that you're like, tell me about it, please. I want your opinions. All right. So let's start from the beginning. The whole story of LLMs and how things are changing, it's down to like the pursuit of this AGI thing. So we're going to start off with a little bit of a history lesson. It is very abridged because time. So these companies have been pursuing AGI, but AGI itself is a loosely defined term. Dario Amodei, he says AGI is a marketing term, and he prefers to talk about powerful AI. So he says, powerful AI is smarter than a Nobel Prize winner across most relevant fields. It can prove unsolved mathematical theorems, write extremely good novels, and write difficult code bases from scratch. There's more to his definition than that. I've summarized it, but this is the tricky part. So are we getting there? So we had a rapid succession of GPT models from 2018 to 2020, and each one was like way more powerful than the last one. In 2020, OpenAI released the Kaplan paper, and that paper examined scale and the effects of scale. They trained GPT-3 on a bunch of data, and they came up with this formula that, like, the performance of a model is a function of the parameter size of the model, the dataset size, and the compute. And they weighted parameter size as the major thing. So bigger is better. Throw more money at the problem and it'll get faster, it'll get smarter. In 2022, another paper was released by a different group, and they trained a different model. This one was much, much smaller than GPT-3, and yet it outperformed GPT-3. So they showed, look, like, parameters matter, sure, but data matters more. GPT-3 was undertrained. In 2024, we had a plot twist. OpenAI released O1, a reasoning model. So OpenAI had been singing the scale song up until now, and then they released something new that was not just GPT-4, but bigger. It wasn't GPT-4 with more money thrown at it. It was something else entirely. So it was an iterative, it made use of iterative chain of thought reasoning. So it's a different algorithm during inference. It's not just like getting it to think for longer. It's about getting it to think in a very, very specific way. Think in rock and roll quotes. Yes. There was a lot of emphasis on post-training and refinement, because we would need to come up with these answers and figure out which one was best. And so post-training became necessary as well. And so there was talk of a new scaling axis, post-training and test time compute. Meanwhile, Ilya Sutskever, he was talking about how we were in a new age of discovery. The 2010s were an age of scaling. Now we're back to discovery again. Clearly, there are some unsolved mysteries here, because when we try different things, it works pretty well. In 2025, we got another plot twist. So DeepSeek made some waves, DeepSeek R1. So you don't need to see this. I know it's small. You don't need to see the details, but pay attention to just the major lines. Oh, that's horrible. Okay, so we've got DeepSeek, and that's in dark blue. It is either the first or the second highest performing model across multiple benchmarks, and it's competing against things like Sonnet, Claude Sonnet 3.5, and O1, and it's doing really, really well. It's doing really well, and it's doing things differently. So R1 made use of a thing called a mixture of experts approach in its inference. So it's a very big model. They trained it on a lot of data, but when you actually ask it a question, it won't use the entire network, it uses a fraction of the network, and so it is more efficient. So that's fantastic. But the thing that was really troublesome, in a way, was how little it cost to train. DeepSeek R3 cost like maybe a tenth of the amount that GPT-4 cost to train. And so that broke the more money, more power argument a little bit. And it also kind of broke NVIDIA a little bit, because they used older GPUs. They didn't have access to the new stuff. So this gives us a little bit of a hint of the kind of economic instability surrounding the stuff. NVIDIA lost $600 billion in a single day. This was a world record. They held the last world record as well. So that's kind of bananas. After all of this happened, Sam Altman was still singing the scale song. He's still saying that the intelligence of an AI model roughly equals the log of the resources used to train and run it. These resources are chiefly training compute, data, and inference compute. It appears that you could spend arbitrary amounts of money and get continuous and predictable gains. So he's still singing this song. So he's basically like, here's an illustration. So he's saying, if we have enough fuel for this rocket, we'll get to AGI. But I'm not convinced that we have enough fuel for this rocket, even if the argument was correct. Compute is hard to get. There are physical limits to what we can do with memory. We are hitting those limits. Money is kind of a problem. There is instability on that front. Training data is not all created equal. So that's difficult. But are we even on the right rocket? Are scaling laws really laws? So we've seen different conclusions from different research papers. I showed you 2 papers. There are many more that argue for different things. We've seen that different model architectures and different algorithms yield different results. And we've seen that inference time algorithms matter a lot. The way you think through things matters a lot. And most of all, there is no foundational theory on why this would work. So we've seen a pattern and we're like, cool, this pattern will continue forever, but maybe it won't. 2025, GPT-5 was released. And it was generally underwhelming. People didn't like it, people were upset, and there's a bunch of different reasons for that. Maybe it's a sign of diminishing returns. Maybe it was a rushed release because OpenAI needed to do something market-wise. Maybe it wasn't well understood by users because it was a different architecture. Yet again, it was a router with a bunch of different models, and so using it you needed some finesse. Maybe it's something like this. So maybe we're climbing this LLM mountain and we're not quite at the top, but we're seeing diminishing returns. But if we wanted AGI, I'm not saying AGI is not possible, maybe it's somewhere else. Is text prediction the thing that we need? There are other players in the game. There are other types of models. It's not just that LLMs are the only one. All right, so what? If we're chasing diminishing returns, what does that mean for us in this room? Well, diminishing returns are actually pretty cool because if you make a model that is slightly more able to succeed on smaller tasks, it is exponentially more able to succeed on chains of tasks. And I'll give you you can build an intuition around this. Like, let's say we've got a human being with an IQ of 70. They'll struggle with a lot of things. There'll be some things they can get right. There'll be some things that they can get wrong. And then if you could wave the magic wand and give them an IQ of 80 instead, it's not like they can do 10 more things. They can do a lot more things, and those things can be chained together into bigger, more complicated things, right? So the same thing happens with coding tasks. We as software developers and engineers know that big problems can be decomposed into smaller problems. And if you improve your chances of solving smaller problems and more of them, you can do bigger, cooler things. So that's great. And that has led to a Cambrian explosion of LLM applications. This is the fatigue that we feel. This explosion is going to continue whether LLMs continue getting better or not. Even if we were to pause development right now, this explosion is continuing because the things that we're seeing now, it's innovations built on human innovations. We've got this tool set and we're still learning how to use it. So it's not going to go away. But what if the bubble bursts? There is a bubble. There are some bubbly things going on. There's a gold rush, and also there is gold. So I'm not going to go into this in great detail, but I just want you to see the fragility of the system. So there are 7 companies that make up this group called the Magnificent Seven in the US, and they make up 35% of the US stock market. How many of them have something to do with AI? Pretty much all of them, right? Apple's a bit of an outlier. They don't quite fit in the same bucket. About half of NVIDIA's income comes from the rest of the Magnificent Seven, except Apple. NVIDIA is very, very tied into the rest of the ecosystem as well. Of course, like so many people are relying on them, but this system is brittle because there are a lot of circular dependencies. We know about circular dependencies here, they're not great. And a lot of those circular dependencies are just like clever accounting. So NVIDIA could do stuff like lend some money to OpenAI, so OpenAI can buy their chips. And there's a lot of really weird things happening over there, and it's creative, it's brittle. What happens if it bursts? What happens if this bubble bursts? So there was a bubble before, once, called the dot-com bubble. And that burst and it was violent, but the internet is still a thing. People tend to overestimate what a technology can do in the short term and underestimate it in the long term. So I'm pretty certain LLMs are with us, the stuff that we have learned is with us, and it is going to change things in a fundamental way. But I'm also pretty certain that the bubble's going to burst. So we should invest in these things. I believe in that. We should invest in using them, but we should invest in using them in a way that is safe. Here is a really interesting graph. So on the y-axis, we have LM arena scores for different models. On the x-axis, we have time. The top line, those are models that are frontier models, running on hardware that we can't afford. The bottom line, those are open weight models that are being run on consumer hardware. They're lagging behind the frontier models by like 12 months, sometimes less. This is just one benchmark. Wouldn't it be nice if there were more? across multiple benchmarks, we can see the same kind of pattern. 6 months to a year is the lag. Of course, like benchmarks, you should always take them with a pinch of salt because teaching to the test is a thing. If model makers are optimizing for passing benchmarks, and they get really good at that, and our situations are all different. So pinch of salt, but it's worth knowing that, like, if, for example, you were using something like, let's say you were relying on GPT-4 for something, and GPT-4 went away, and you just switched over to like Qwen 3, which you could run on consumer hardware, you should be okay. You should be okay. But you should test. You should check. So there is strength in diversifying the models that you rely on and lean on. So you don't necessarily always need to use the latest, greatest stuff. It's useful to be able to rely on different model providers, not just one. And it's also useful to provide more guardrails for what you're doing. So remember what I said about diminishing returns. You yourselves can build those diminishing returns like through the tools that you use. If you have better ways of catching errors, you can make your stuff more right in smaller tasks. So that's great. All right. It's also important to talk about the job market because we got to eat, right? So in 2025, the job market it hit something like a 5-year low, I believe. So this graph here is the software development job openings in the US, which is not here, but it's things tend to follow a similar pattern. So we're looking at the top line. Early on, pre-2020, we had a recession, and so there was a drop-off in jobs. And then COVID happened, and interest rates were really low, so there was a lot of free money, so people hired like crazy, and they overhired. And then they needed to fire some people and right-size. So that's a lot of this drop-off. So I don't want to minimize the effect that AI has had on jobs, because it has had an effect on jobs. Like, I was sitting in the speaker's room before this, nervously reading over my slides over and over again, and a bunch of the speakers there were talking about how they got laid off. Entire divisions of their companies got laid off because it's like, oh, you're not doing AI in your division, we'll just can it. So it does affect people. I don't want to minimize that. But there are other forces at play as well. So when an organization right sizes and fires a bunch of people, then they're not going to overfire. They're going to be saturated. The seats are filled, and so they're not going to have job openings. So that doesn't necessarily mean that there aren't jobs. It means that the seats are full. So yes, also AI. If we look a little bit further along and we zoom in a little bit, we can see that tech job openings are actually increasing slowly and steadily. Looking specifically at tech startups, tech unicorns, and public tech companies, these are American stats. So that's cool. What's happening? There's a bunch of things that are happening. So there'll be natural attrition in jobs. So people leave and they need to hire new people. So that's great. Vibe code, vibe coding is messy, but it does actually lead to more opportunities. It leads to more creativity. It leads to really fun new jobs. Lol. Vibe code cleanup specialists are a thing for a reason right now. But also it leads to more entrepreneurs. The fact that it lowers the barrier to entry for people who can make proof of concept, who can say, like, I've got this crazy idea, and they can hack something together and they can make it sort of limp along. That's great, because it means that there's more space for folks to come in and productionize these things. So there's more creativity, there's more human creativity. And there's new jobs as well. Like, security becomes very, very important in LLM land. There's all sorts of new and interesting ways to get hacked, and that's, it's interesting. Observability becomes very important. Operationalizing these things becomes important. It's not trivial stuff. Like, that is deep tech. It's not like, it's not something to be sneezed at. So place your bets. Earlier on, I asked you, will software engineering be a thing in 5 years? And pretty much everyone put their hand up. So for those of you who did not put your hand up, let's talk about what software engineering is, right? It's not just lines of code. One thing that I noticed when I was doing the research for this talk was that software engineering seems to be fairly misunderstood by a lot of the people who are writing about how it's going to disappear. It's like, oh, it's not about the syntax anymore. It's like, it was never about the syntax. what do? We write code, sure, but we embody a whole lot of different characteristics as well. There's process thinking, system thinking, critical thinking. There's things like precision in communication. The way that we communicate with the machine is through code, and that is the most precise way to do so. And that shows us the flaws in our own reasoning. English is a blunt instrument. We are very good at sniffing out edge cases and understanding them. We are very good at dealing with uncertainty and designing around that uncertainty, hedging our bets, deferring decisions and designing around that. We are very good at knowledge management. That's what code really is. We're good at learning. We're good at experimentation and research. When you see a software engineer who's successful, they're this. There's grit, there's mental discipline, and there are habits of validation. We can check ourselves in ways that a lot of other people never needed to. And this is gold. This is gold whether people are writing code or not. So I believe in software engineers, and I believe in that set of skills. How do we build these skills? Well, by doing the reps, right? Junior devs are in a funny place. So a lot of you said that you believe that there will be a need for software engineers in 5 years. Let me just get a show of hands. Who of you are technical leaders in some way? Okay, fantastic. So that's a lot of you. Where are you going to find these developers in 5 years? Where does future talent come from? So I mentioned boot camps earlier. There was, when we had that spike in hiring, we also had a spike in boot camps. There was another gold rush and a little bit of a crash on that side. We have learned that there are some good boot camps. They are out there, they exist, but there are also a lot of shocks. Probably you shouldn't place your bets on boot camps. Should you place your bets on universities? Universities can only train people to a certain level, but it tends to be fairly general in a way. If you work for a big organization, whenever you hire somebody, even if that somebody has years of experience, you need to train them on your particular use of the tools. And so universities maybe are helpful, but they don't manage the last mile. I'm personally very bullish on apprenticeships and grad programs. Organizations who want to have a talent pool 5 years in the future should probably do something about the fact that there is a vacuum at the moment. There is an apprenticeship crisis at the moment. So if you're thinking to the future, that's a big part of it. All right, so yeah, I'm doing well on time. That's amazing. I was worried. So now I'd like to zoom in on organizations and how I think they should adapt. I've sprinkled a bunch of advice throughout this talk already, but this is specific. I'm going to talk about organizations because a lot of the advice that I would give to an organization trickles down to the individuals in it. So you should be able to derive the individual advice for yourselves. All right, so I think it's clear. It's important to invest in AI adoption. It is changing things. You need to learn the skills and do the reps, and things are going to change, and you need to be able to change with them. You need the muscle. But when investing in AI adoption, where should that investment go? Where should the resources go? There's this thing called the 70-20-10 rule, and that came out of some research done by the Boston Consulting Group. So they spoke to 1,000 CXOs and senior execs over multiple sectors, multiple countries, and they looked at where value comes from. They're where's the ROI, where's the return on investment? They also looked at the types of problems people were facing. It's oh, why is it falling over? You invested in this, and then what happened? Where's the ROI? And they came up with this rule. So 70% of resources should go towards people, 20% to data, infrastructure, and tools, and 10% to AI models and algorithms. So AI models and algorithms, that last 10%, that would be your subscriptions to the models and what else? Whatever else. So investing 70% of resources into people is quite a big thing. You hear about all of these big companies firing lots of people. That's not the best move for so many reasons. You'll see some of them now. So when you're investing into people, what are you investing in? There's culture. That's quite a big thing. It's not just a shiny word. It actually really, really matters. There's training and education. And there's structures, so the ways that people interact with each other, the way teams work, things like that. Now, when investing in culture, one of the major things to think about is psychological safety. So MIT did a study, and they looked at 500 business leaders, and MIT, they know stuff. They're pretty good. 83% of those leaders believed that a company culture prioritizing psychological safety measurably improves AI success. Fantastic. 84% observed connections between psychological safety and tangible AI outcomes. Fantastic. Leaders in the room, do you believe that your teams have very high psychological safety? Can I get a show of hands? All right. Cool. So that's fantastic. 39% of the organizations that MIT surveyed rated their psychological safety as very high. Now, personally, I think that this number is a bit inflated because it's hard to judge these things. You can think that everything's swell, and it's not, because things get a bit, like, you need to be very intentional about getting a good read on psychological safety. You can't just thumbsuck it. But why is it important? So many people believe in it, but why? What's the connection? Well, as mentioned earlier, we are in a new age of discovery. And that new age of discovery is not just limited to the folks who are making the models, it's us as well. We've seen that rise in tools to do with AI, all the different LLM wrappers and all the different best practices and worst practices and security things. Like, we ourselves have a lot to learn. AI fatigue is a thing, and AI is best explored together. Software engineering is thought work. We use our brains, and we use our brains to create value in different ways. What is best practice in your organization might not be the same as your organization, because you have different values, you have different clients, you have different risk profiles. Everything's different. So you need to do some discovery on your own, and you need to do discovery in a way that works for your organization. And change is hard. That's the other thing. Adopting these tools isn't just a checkbox exercise. It's adopting practices and new ways of working and new ways of interacting with people. Change management is a whole field on its own. It doesn't happen just by itself. You can't just decide, we will do this now. One of the things that's really important there, again, is that people can want to change. People can decide to change. But it's hard. I mean, who's tried to quit smoking or YouTube? It's hard. It's really hard. Peer-to-peer accountability helps a lot. And peer-to-peer accountability is not something that's really that possible without psychological safety. For many people in many jobs, accountability sounds like a stick. It's not something that's actually empowering, but it can be. All right. So people are scared. People are scared for a bunch of reasons. They don't want to lose their jobs. And there's more fear in organizations with higher AI adoption because there's a lot of people making decisions on hype. So I would say a really useful way to play the long game is to address those fears directly. So partially invest in psychological safety. Don't just say it's a thing. Actually, put in time, do the reps. Don't just do a team building exercise. There's more to it than that. And then try to find ways to use AI to make employees' lives better. Jobs are changing. The types of jobs are changing. I heard about a company who built out some AI tools to help their employees with internal mobility. They're like, cool, stuff is changing. Why don't you enter into this machine, what you want to do, where you want to go, and we will try to craft for you your own unique and special career path. And that was great, and that improved retention. And there's other examples of things like that. There are ways to make life better. The other thing to do is make it safe to experiment and fail. That doesn't just mean putting posters on the wall that say fail fast, fail forward. You can be quite intentional about this as well. People don't know where they're allowed to fail or not. So what you can do is you can say, these tasks here, experiment, go wild, fail, break stuff, we're happy, tell us what you learn. These tasks over here, be careful over here. Always validate the outputs. You can experiment, but don't let it go past this point. Put in guardrails, give people guidance, show them where they can fail, and then they're more likely to experiment. And make it clear that knowledge generation is a part of the game. So on job security, PwC did a very, very big study. They looked at close to 1 billion jobs. It's a lot of jobs. They saw that In 2023, AI-skilled workers averaged a 25% wage premium. 2024, that increased to a 56% wage premium. So whether or not a person is going to stay at a company, it's good for them. It's good for people to get their heads around this stuff. The skills sought by employers are changing by 66% faster in jobs most exposed to AI as well. So yeah, it's good for people. Support them to learn. All right, but how do you support people? Training's great. Now, I assume that everybody in this room probably has some amount of AI skills within their organization. Am I right? Yeah? Everyone's nodding? Fantastic. Subject matter expertise and teaching expertise are two different things. There's overlap. You need to know your stuff in order to teach your stuff. But if you are doing some kind of internal training program, I'd highly recommend putting effort into learning how to teach well, because there is a craft to it and there is a science to it. It's also important to make time. This seems like an obvious thing to do, but a lot of organizations say that they value education, but then they don't actually make space for it. So that's not great. It's also important to support people through knowledge and tool management. If an organization is big enough, then it's useful to have something like an enabling team that can set up scaffolds and guidelines for others to follow and set other people up for success. Otherwise, you can just have a central repository of best practices. That is helpful. It's useful to reward collective performance instead of individual performance as well. All right. So if you get this right, and now everybody's using AI and they're experimenting and life is good, you have all of these AI-augmented humans. You have these centaurs running around. They have more agency, which is fantastic. Like me, myself, I can't do oil paintings, and you saw those oil paintings? That wasn't, not oil paintings, watercolor paintings, you can see. I can't do that. Now I can do that. But the thing is, I now have a bigger blast radius. There are more things that I can get wrong. There's more things that I can do, but without necessarily understanding the fundamental skills in those domains, there's more that I can get wrong. And I can get them wrong faster. So I have a bigger blast radius and I have more bombs. Alignment is more important. If you have empowered people and they're running in the wrong direction, that's not great for anyone. So how do you get people aligned? Again, culture, values, ethics. People need a bigger picture understanding as well. If you want people to do bigger things that make sense within an organization, they need to understand how that organization sits in a larger ecosystem. So that, again, is super important. And all of this can come out of training and intentional interactions. So this is all investing in people. Now, I've spoken a little bit about some of the dangers of people going in the wrong direction and setting off bombs, but there are some other challenges we have with AI. So let's say you have a silly question. You're not necessarily going to go and talk to your respected colleague about your silly question because it feels silly. You might talk to an LLM instead. Let's say you have a complicated project and you want to onboard a new team member onto your project. Maybe you'll get an LLM to do it instead of doing all the heavy lifting yourself. Human connection breaks down. There is more loneliness, and there's also a decrease in people's ability to do critical thinking. So I will illustrate this. Has this happened to you? Where you ask an LLM a question and then it's like, hey, here's the answer, and you're like, sweet, I can just stop thinking now. I don't need to consider other ways that this can be done. It's very easy to get anchored on different things. It's very easy to go to an LLM and say, I have this bright idea, and it's like, wow, you're fantastic, well done. But if you were to go and talk to a human, maybe they would yes and your idea, or maybe they'd shut it down, and that's uncomfortable. And so it's important to talk to people. Richard Feynman said the first principle is that you must not fool yourself, and you are the easiest person to fool. LLMs are great at helping you fool yourself, so you got to look out for that. Okay, so we've been talking about all the squishy stuff. Let's talk about some code. There's a new bottleneck, right? This is something that a lot of people are talking about. They say, since we can write code so quickly with LLMs and we can get them coding in parallel with agents and what, reviewing code is the new bottleneck. People need to make sure that the code is good quality. Here be dragons. Be careful of this. Why? So we know AI-generated code has more security issues. It has more logic issues. It's got more weird bugs because of unexplored edge cases. It's got more readability issues. It can be pretty convoluted sometimes. And we know that even debugging our own code can take longer than writing the code in the first place. Debugging the weird code that comes out of an LLM is pretty difficult. So Cory Doctorow has a lovely article about reverse centaurs. So a reverse centaur is a machine head on a human body, a person who is serving as a squishy meat appendage for an uncaring machine. An uncaring machine would probably give you really big, messy pull requests to review. So reviewing reams of code that are statistically indistinguishable from working code, like that's not a really great way to spot bugs. The code will look right. You can have a one-line issue, like problem in your code that turns off all your security. This happened to me the other day when I was trying to get an LLM to help me with the thing. I was like, whoa, one more line, but you turned off everything. It's no good. Now, LLMs are going to get better. They're going to get way better at writing code. This is fantastic. Bugs will become more rare. And if something hardly ever happens, it's going to be harder to spot. So the people who are put into these positions as the reviewer, as the final check, they're being set up to fail. The human in the loop becomes the accountability sink. The human in the loop is the person who can now get blamed if the code doesn't work. So this isn't always done in a nefarious way. It can be done in a careless way. I mean, it seems logical that it's like the LLMs can write code and the people can do the quality check, but it's really important that if you're putting a human in a loop, you need to design with humanity in mind. People are prone to certain human errors and cognitive biases. The more that we design our systems with those in mind, the more robust they will be. To err is human. We need to account for that. If you expect perfection from a person, like reliable perfection from a person, then the system is not designed well. So, so it can go badly, but it can also go very right. So Stanford did a study on developer productivity, and they looked at more than 100,000 engineers. They looked at billions of lines of code. They looked at millions of commits. They looked at a lot of private repos. They looked at work repos, not open source hobby repos. And they came up with a bunch of conclusions. On average, LLM-assisted teams are 15 to 20% more productive than non-LLM assisted teams. That's cool. There are caveats. So greenfield projects benefit more than brownfield projects. Simple benefits more than complex. And popular languages benefit more than rare languages. If you're doing a COBOL project, maybe an LLM isn't the best bet. Also, if you set things up wrong, you can decrease productivity by 20%, probably more. So it's important to think things through and to use them for the right things. So if you're making technology choices, try to think about things that give you clean context by default as much as possible. So clean code is a great thing for an LLM. LLMs aren't great at making clean code. So that's a bit of a conundrum. It's good to clean things up, and it's good to use your human mind to do so. And it's also important to choose tools with simple context. So I have a fun rant about HTMX versus React. Come talk to me later if you want. All right, so successful AI adoption. If you adopt AI successfully in an organization, then the humans in that organization have more agency and can do more stuff. Human dependencies change. Like for me in this presentation, I wouldn't have to go contract a painter to make me some pictures. I can just do it myself. In an organization, people have been forced to rely on each other in different ways, and now they don't have to as much. Bottlenecks change as a result. So things change quite a lot. Now, organizations that adopt these things and do so successfully, they create some value, right? There is some kind of return on investment that is occasionally very, very hard to measure. Where does the value come from? So there's two major buckets of value. The one is optimizing workflows, taking the stuff that you're already doing and making it better, faster, stronger, automated as much as possible. And then there are core business activities. There are things like building out new product lines, creating new things that you can sell to your customers. Now, the organizations that win the most, according to BCG, the organizations that create the most value, they focus on core activities. So they take some big bets, they take some bold bets. It takes a little bit of courage to get this right. And organizations need to change in order to allow that to happen. So how are organizations changing? This is also something that came out of the BCG study. It's like, what are these organizations doing? What are these organizations doing differently that others can potentially adapt? So the first thing is that organizations are abandoning org charts, and they're instead focusing on dynamic, high-agency, project-based teams. People can get more stuff done, and their skill sets aren't mapped to individual roles. Folks aren't as bucketed into specific positions. And so you need to be able to Tetris people together in more interesting ways. But this is difficult. You've all heard of storming, norming, and performing. There's more storming and there's more norming if you keep changing the shape of things. Like sometimes if you put a group of people together, it'll take them like 6 months to learn how to play nice. It's like even if they're good, solid, productive human beings. So you need to shortcut that. That again comes back to things like psychological safety. So if you're in a high trust organization, storming is shortcutted. If people are more connected, then that's shortcutted as well. If life is more transparent, then it's better. Like if I need to now work with a complete stranger, that's going to be harder than me working with somebody that I actually know, even if we haven't worked together before. They also make use of shorter planning cycles. So there are some downsides to that. I mean, shorter planning cycles make a lot of sense because things are changing so quickly. If you wait 3 months to make a decision, that's no good. But short planning cycles can have downsides because you can get that shiny new toy syndrome thing. And so you do still need to adjust around that. So things like protecting attention and closing loops and biasing actions towards actually finishing things is more critical now than it was before, if we're changing that. Lastly, a thing that they do is they rethink existing workflows. If you're changing people's roles and how they interact with each other, if you're changing how work gets handed off, you need to rethink workflows. It's not just about taking an existing workflow and saying like, cool, which pieces of these can we automate? It's about taking the whole thing and saying like, do we need this or do we need something else? So that's important. Okay, but let's say you go all in on this stuff and you change your processes and you have a bold mission and you create new value propositions for your clients. Like what happens if the bubble pops? Is this all just risky advice to follow? So remember these graphs from earlier. If you are relying on the latest, greatest models for everything that you do, then that's not great. So sure, like use the latest stuff, experiment with it, figure out what you need, and then see how much you can scale back. You'll save cost, you'll save money in the short term if you don't need to rely on the latest stuff, but you'll also build in like that stability and that flexibility. Focus on using the models well, build the muscle. If you're using the best stuff out there, then maybe you don't need as many guardrails. But if you can build the guardrails yourself, then you are more able to have a future-proof product. Focus on benchmarks and monitoring. Like monitoring is so important with LLMs, especially like if you've got an LLM in production, if you've got some kind of wrapper around it and that's a product. Even if nothing changes about the model, your product can shift in how it behaves. Like if you change the infrastructure that an LLM is running on, then the LLM will behave differently. This is the thing. Focus on good context. Good context and good documentation kind of have a lot of overlap. Documentation saves lives. Focus on guardrails. Focus on good testing. Focus on flexibility rather than lock-in. And build tools that allow for safe experimentation and rollout. A lot of organizations get to a point where they have people experimenting with LLMs and they have people building out these proof of concepts. And then it's like, I think it was like 47% or so of proof of concepts don't get beyond proof of concept. Like they get there and then they get stuck and then they don't add any more value because integration is hard. Integration into technical stacks, but also into human workflows is hard. So figure out how to do that. Like figure out how to almost be like a factory of like actual implementations. So remember that 70-20-10 rule that I mentioned earlier? We spoke a lot about people, that's 70. This year, that's the 20. So the 20% infrastructure and business tooling and whatnot, that's the stuff that makes you future-proof. So I'll close off by bringing some stuff back to the individuals. For a human in this place, it's not, like I'm not gonna make specific technical, recommendations. I'm not going to say you should handle long running this and you should use Claude Code or open code or whatever. Like, focus on honing the craft. It's kind of the same advice that I'd give to a junior. Focus on honing your craft. Because with LLMs, we're kind of all junior-ish because we're all quite new to using these tools. It's an unproven domain in many, many ways. Focus on building up skills around communication and orchestration. That is something that I think is quite critical because in the end, you would be orchestrating these tools. This feels a lot like a management skill set. Who wants to be a manager? Maximize your agency and solve problems. Don't just stick to what you can do with code. Think about ways that you can expand your agency beyond code. And be willing to re-examine foundational beliefs about what a software developer, software engineer does and what makes good code. I mean, there's so many reasons to like quickly write throwaway code now. You can do so much more. You can experiment so much faster. We're used to working in a very deterministic way. This is different. So be prepared to challenge yourself in that way. Cool, that's it. Thank you.